Hello everyone, I am excited to introduce our next presenter, Withnall. He will be talking about how we can make our project more environmentally friendly. Good luck, Flip.
Thanks. So welcome. I'm going to talk to you about how you can make your project more environmentally friendly. The aims of this talk are to help you to help the environment, increase knowledge about where environmental costs lie and how to avoid them, establish an endpoint for this process, so how environmentally friendly do you have to make your project and how much does it matter, and to lay out questions which still need answers. Some of you may have been at Ditch's talk on the first day of the conference. If you weren't, I recommend checking out the recording. While his talk looked at helping users to identify applications which are consuming power on their computer, my talk will look at helping developers reduce the environmental impact of a specific application that they work on. So, this is the same slide as in my talk on the environment last year, and it's still as relevant, I think. It provides a bit of context and motivation for the entire talk. Global greenhouse gas emissions need to decline by 45% by 2030, so that's in 9 years' time, and to reach net zero by 2050 in 29 years' time. Net zero is where all greenhouse gas emissions that can't be eliminated are balanced by carbon absorption in the environment, say by growing trees, or by using as yet non-existent carbon capture technology to suck it out of the air. Throughout this talk, I'll use carbon dioxide as a proxy for all greenhouse gases, just to simplify things, and I'll also use energy and carbon interchangeably because, for the most part, they are. All energy production has a carbon cost of generation, and I'll cover that shortly. The longer it takes for emissions to reach net zero worldwide, the higher the global average temperature will rise, kind of like coasting on a road. So early reductions are better. Typically, warming is expected to be greater than 1.5 degrees C on land and less than that on oceans. So, making and running software emits carbon, and in order to be able to reduce environmental impacts, those emissions need to be measured. One approach for that comes from the product manufacturing industry, and that approach is the life cycle analysis of the carbon emitted during manufacture, which is said to be embodied in the product, during use, and during disposal. In LCA, a functional unit, it was a well-defined term, is defined as a certain quantity of the product being analysed, chosen to make the analysis well-defined, scalable, and comparable between different products. So, for example, a functional unit in one analysis might be a single car produced and driven at 6 litres per 100k for 300,000 kilometres and then scrapped. A system boundary, which is another well-defined term, is defined, which includes all the raw material inputs and all the processes which are involved directly or indirectly in manufacturing, transporting, using, and disposing of the functional unit. In the case of a car, this would be the raw material extraction and processing for the metals and the plastics and the rubber and so on in the car, the manufacturing of the car itself, delivery to its owner, the oil extraction and the processing for its fuel, and then the emissions from driving it, and then the emissions for energy recovery and material recovery from scrapping and recycling whatever you can out of the car at the end of its life. This kind of analysis is fairly well understood, if not universally adopted, in the manufacturing industries, and it's standardized as the ISO 14000 series. So just like cars, software has embodied carbon costs. Those costs don't come from raw materials, so get rid of that, or from burning petrol, but they come from building and powering servers. So there is some raw material extraction going on. Powering networks for data transfer and providing the equipment for doing that. The marginal power usage of the software on an end user's computer, which is the additional power usage compared to if the user wasn't using that software. And about the only part of the life cycle of software which doesn't emit carbon is disposal of software, although disposal of servers probably will. So all adds up. Most software carbon emissions come from generating the energy needed to power hardware, and hence they depend hugely on the carbon intensity of that power generation. So, for example, coal, everyone's favourite, is very carbon intensive. You burn coal, you release carbon dioxide. Solar or hydro, much less carbon intensive, but they still have some emissions because you still need to build your hydro power plant with a lot of concrete, or you need to build your solar panels and manufacture them and build the factories for that. So these carbon intensities factor in the entire sort of supply chain of producing that electricity. It's quite hard to get figures for the intensity of the electricity you're using, so I've kind of used an average of 300 grams of CO2 equivalent per kilowatt hour throughout most of this presentation. Other emissions come from embodied costs of the hardware itself. So there's roughly 1.2 tons of carbon dioxide emitted to manufacture a 2019 Dell server, and that's not including the costs of running it or disposing of it. And the embodied cost of a laptop is about a quarter of that, so about 300 kilos of CO2 just to build the laptop. I've recently bought insulation for my house, and when buying it, you can look at the data sheet, or before buying it, and you can see what the lifetime carbon cost of making the insulation is, and then you can calculate carbon savings from not leaking heat from your house into the outside environment. So this allows you to compare insulation from different manufacturers on the basis of the carbon cost, and they do vary quite radically by an order of 2 orders of magnitude, I think. I'd be happy to be corrected, but I know of no analyses of the embodied carbon costs of software. There's plenty of analyses of hardware, but not software. So this is an area where Gnome, I think, could improve the state of the software field. I think people are eventually going to want to know the carbon costs of software they procure, especially if they're a business or a government and are operating at that kind of scale. And we could provide that information, just like the manufacturers of insulation do, and just like we already provide information about software licensing, and people already make decisions on that basis. In order to do a rigorous analysis, there are various complications like direct and indirect rebound effects and transformational changes, which would need to be accounted for, and I've ignored them for now for the sake of making some progress, but hopefully more rigor can be added over time. So let's try and do a rough lifecycle analysis for software in Gnome. Here's the functional unit that I'm going to use, one distribution table of a software release. This is the thing we want to measure the lifetime costs of. And here's the system boundary with some nice colours. So the system boundary contains the processes which we are directly or indirectly responsible for, which emit carbon throughout the lifetime of the functional unit, which is our dist table. For certain parts of the system, it might be easier to measure costs in aggregate. So, for example, the power consumption of all of Gnome servers, or the carbon emissions of the foundation, or conferences. But for other parts of the system, it might be easier to measure costs per functional unit. For example, the cost of all the CI pipelines you run in order to do one release of your software, or the costs of Hackfest at some point during your software development to get a certain feature done or something. So as long as we're careful to not doubly count costs, splitting things up like that should work out okay. Why is it important to look at the whole system rather than just running profiling tools on your app? Because looking at the whole system counts the project-wide costs and gives an incentive to reduce them, which wouldn't exist otherwise. If you only did profiling on your app, you'd only be looking at these costs here. So that said, let's firstly look at these costs here, the marginal ones. The marginal costs of your app on a user's system are all of the resources it uses whilst installed or whilst running. So that's disk space, memory, compute time, network bandwidth, that kind of thing. While the improvements in power usage you can make to your app are likely quite small, then multiplied by the number of users of the app, which is likely quite large. So based on some of the analysis I did last year, I estimate the marginal costs like this are the largest overall environmental impact that Gnome has. And if you want to see more about that, take a look back at my talk from last year, last Craddock. There are various conventional tools for measuring and improving these marginal costs, but probably the first tool you should use is to just think about your software. What use cases is your app for? How does it serve them? And does it serve them in an energy efficient way? So, for example, if your use case is allowing the user to listen to music, is it energy efficient to stream the music from a server on the internet all the time, or is it more energy efficient to store it locally? That's an example of the kind of question that you should be thinking about. Obviously, there are other considerations to bear in mind, but it's all about finding a nice balance between them. Another example, if your use case is for the user to process data in some way, but your software requires the data to be in a certain format, and sometimes that means that the user has to spend half an hour manually reformatting the data before they can run your software, then your software has caused them 30 minutes of extra computer use and frustration, and that has costed energy. So sometimes adding features or making sure that the functionality is appropriate is going to improve the environmental impact of your software. Other tools are available to pinpoint more specific energy consumption issues. So frequency CPU wake-ups or network usage or disk I/O, they're the biggest consumers of energy in an app, typically. So as a rough guideline, 1 hour of heavily using the CPU will emit about 6 grams of CO2, based on a 20-watt power swing. 1 gigabyte of network traffic will cost you about 17 grams of CO2. And you can explore this by using sysprof from within Gnome Builder or sysprof cli on the command line. They're both equivalent. Here's a screenshot of sysprof being used in Builder to profile Gnome software. It basically plots various different measurements on a timeline. So you've got time increasing that way, and you've got all these different lines here with different measurements of the CPU usage or the network usage of the I/O bandwidth. And there's some recent work in glib, which is merged but unreleased, and in libsoup, which is unreviewed and unmerged, but hopefully will go somewhere, to improve reporting of key wake-ups in glib and network activity, HTTP requests in libsoup. Systemd is another tool you can use. Supports accounting of various resources which processes use, and this is kind of related to Benjamin's talk earlier. It can, if you enable the accounting functionality by using this command, it will turn on all the accounting for all the units on your system. And with the recent work to use systemd for user sessions, that means it'll get enabled for user session units as well. And will produce results like this. If you run system_status status on a service, it'll give you an overview of the total network bandwidth that's been used, or the total disk I/O bandwidth, or the amount of CPU time, and an indication of the runtime as well. So you can look at system_status for your app and find out what it's been doing at a more high level and over a slightly longer time period of like one whole session or something, which will give you an idea of where the big costs are. So for example, GeoClue, not quite sure why it's downloaded 8 meg of stuff just to find my location. So maybe there's a bug there. At an even higher level, PowerTop is an established way of estimating the power consumption of processes and of various bits of hardware on your machine. And it can provide some insights into the power consumption, particularly caused by wake-ups from your process, which add up quite easily to cause a lot of CPU power usage. These occur whenever your process wakes up to handle input or timer events or idle callbacks or ongoing disk I/O network traffic. And to reduce the power consumption, you need to group them all together. As per Aditya's talk at the start of the conference, we may eventually get a breakdown like is provided by PowerTop within Gnome usage. So moving now to look at the embodied cost of a specific release of some software, like the specific costs from your software rather than from a specific release of your software rather than the marginal costs, sorry. CI, continuous integration, is an ongoing cost of development, and its main carbon cost is CPU time. But network bandwidth also adds a bit, depending on how you've got certain things set up. So especially if every CI pipeline downloads the dependencies for your project from scratch, that'll start to add up to be quite a lot if you run your pipelines quite a lot. So the formula here estimates the number of the cost of CI for a project over whatever unit of time you set. So you could say what was the average run length for a pipeline in the last month, and how much data was downloaded by each pipeline in the last month, and then times it by the number of pipelines that happened in the last month. And if you do that all, you get numbers like 4 kilos of CO2 out, which is what I worked out for glib per month, which I think is not too high. It's not zero, but it's reasonable. For comparison, so it comes out at 4 kilos per month. For comparison, the target emissions for one person for a year are 4.1 tons, of which that would be 1.2% for doing all of the CI for glib. The other bits of the system boundary diagram from earlier are a bit harder to measure, and work is still ongoing on measuring them. So there's not really enough information to report about it in the talk yet. Sorry. GWADEC this year is being measured to provide a comparison against the carbon emissions from an in-person conference. So we've got some data from the last 2 years of GWADEC, and hopefully can collect a bit more next year if we do an in-person GWADEC. And we can see how the different options compare and where there are possibilities for savings without affecting the experience of the conference. Thanks to Bartolomei for getting the measurements set up in time for GWADEC to start this year. I'll be looking at the results and hopefully publishing something about them once the conference is over. So, that's the slide about that. Once measurement is done, improvements can happen. And at what point do we stop making improvements once we've started? It's like, do we get to a stage where an application consumes zero energy for doing everything? Obviously, that's not possible. So my current thoughts on this are that it's a bit of a competition. If two pieces of software provide the same functionality, rationally, users and distributions will choose the one with the lower embodied and the lower marginal carbon costs. I suspect in many cases it won't be that clear-cut, but that's the principle. These costs should be budgeted for by the user who's running the software. So just like the carbon emissions from buying and driving a car should be budgeted for by the owner and the driver. And car manufacturers can then compete on producing cars with low embodied and marginal emissions. So the improvements you can make to your software are all of the standard ones for performance. Allow the user to work more efficiently by spending less time on the computer, do less work, use less CPU to do it, use less network bandwidth through compression and through caching and through bunching network requests together to reduce round trips, and do the same for disk I/O. CI pipelines are quite easy to improve. So unless your CI pipeline is run very infrequently, like a few times a week, then you should pre-build a Docker image containing all of your dependencies and then run your CI jobs using that image. So that will avoid network activity on each CI job, which is quite carbon intensive, and it can also spuriously fail, and that's quite annoying for development. It also means that you don't have to wait for the downloads to happen of all your dependencies, And when I've implemented this on various projects so far, it's sped up the pipeline by about a factor of 4. Using shallow clones for cloning the Git repository into a CI runner it won't really speed things up, but it will reduce the network activity. And there's a simple option you can set for that in GitLab, which I've blogged about recently. So, as I said, we're still in the process of measuring other Gnome project overheads, such as the cost of server infrastructure and the cost of the foundation as an organization and as an employer. Once the measurements are done, then some recommendations can be made on the basis of the data, and we can see how those costs get split up between different projects within Gnome and how they compare to the costs of the project themselves. So, pulling it all together, Gnome apps, I think, should be labelled with their embodied carbon cost, just like they're labelled with a license. And that cost is their share of the costs of the Gnome project and the foundation overheads, plus their costs for continuous integration and hackfests that apply to each functional unit, each release of a piece of software. We don't have all the data for that yet, particularly around project-wide overheads, but we should collect it, and we should refine our analysis as more data comes in. Those embodied costs should be reduced based on the data we measure by optimizing the CI, by making Hackfest carbon neutral, by switching the foundation servers to be using a carbon neutral power supply. There's various options. It depends on what the data says. And we should reduce the marginal costs of apps by making them faster in all the normal ways that you optimize software, but making sure also that I think the key thing is to not have the user use the computer for longer than is necessary, because a computer has a certain power needed to be turned on from scratch, and then the marginal power increase of the laptop or computer when it's working hard versus idle is a small fraction of that. So the best thing to do is not have the computer on in the first place. There are so many open questions about where the data is inaccurate, or there are wide error margins, or things we just don't know. How many users do we have? Still don't know that one. Can we collect better statistics about user systems, like which apps are used the most, or which ones use the CPU the most? We have no framework for that. That would be nice to have. Other lifecycle analysis impacts, there are various standard ones, most of which don't apply to Gnome, but we still haven't done any thought about that at all. So there's lots. And if anybody's got any ideas about any of these questions, please get in touch. And that's it. Please go out there and see what you can do to improve your applications, improve your CI pipelines. That's easy. Mostly, I think the improvements will be CPU usage and network usage. I think we're not great on at the moment. Sometimes it might make sense to add or rearrange features to make better use of the user's time. So please get in touch if you've got ideas or feedback or want to discuss things further, either about application profiling or about the climate crisis in general and how it all applies to Gnome. If you want to check my analysis, please check out the Git repository here. And there's a bibliography in there which has a number of references, and if you want to read just one of them, make sure it's that one. It's a 15-minute read. It's really easy, but it covers most of the major topics about climate change. And that's it. I'll take a look at the questions now. If you have any questions, please put them in Etherpad, which is linked to in the shared notes on the left. So, first question, have you calculated the carbon cost of something you've made? No, still a work in progress. Various of the numbers in this presentation are parts of the solution to working out the carbon cost of glib, but I'm not there yet. In particular, there's still some thinking to be done about how to attribute the cost of dependencies, which I haven't got a good answer for yet. So it's all a work in progress, but we're getting there. Second question, Are there models from other industries that would show what carbon emission labeling or reporting would look like that we can learn from? Not that I know of. There are standards for carbon emission labeling and reporting, and there are a lot of different options, and nobody's yet done it successfully in a consumer-facing way. A lot of what's out there at the moment is for business-to-business sales of things. If you've got any ideas of things that do exist and do work in certain contexts, please let me know, because there's also a lot of literature out there, and I haven't read it all. I have read quite a lot, but not all of it. Third question, do you think there is space to create harder policy guidelines down the road, or even just best practice guidelines? I think there is. I think from the experience after the equivalent talk I did at GRADEC last year, people aren't fans of harder policy guidelines without data to back it up, which kind of slows down a lot of policy improvement, but also means you don't do the wrong improvements. So I would hope there is space to create harder policy guidelines later down the road, but I think we should probably start with softer ones or things that we can be fairly confident about. Next question, if we label apps with the carbon cost, will it be easy to include costs of system services, so my GeoClue example, or should we also label the core of Gnome separately? Don't know. So the labeling I'm thinking of is labeling the embodied cost of a release of a piece of software. I'm not thinking of labeling the marginal cost of running it. So that said, I think the question is working on a slightly different basis from what my thoughts were about labeling. But there's possibly also scope for labeling that, or maybe providing some insight into power usage from certain apps as you run your computer, which is probably more what people want, which is what Aditya was talking about in the first talk at the conference, answering the question of like, why is my fan running so hard? I didn't think I was doing anything really intensive on my laptop. Where's the power going? Next question. Could someone theoretically...
Thank you, Flip, for your talk. And we are a little bit out of time.
Cool. I'll catch people on chat afterwards to answer the rest of the questions. Thank you.
Thank you very much.